Welcome back to Descriptive Statistics. So we have already seen what is measure of central tendency. Now let's see what is measure of spread. Now central tendency basically summarizes the data around the center, or it is based on the average observation of our data. But it does not tell us how the spread of the data is. So to measure the spread of the data, we need measures of spread. Measure of spread is also called as dispersion. It basically answers the question how much the data varies. So variation causes fuzziness in the world and the data. And to measure this fuzziness, we need to summarize this data and therefore we need measure of spread. Measure of spread, also referred to as measure of variability, provides us the information about the degree to which the individual data point deviate from the average value in the distribution. So average value is being determined by the measure of central tendency, and deviation from this average value is measured by the measure of spread. So we have four parameters to find out the measure of spread or the deviation from the mean. First is range, second is interquartile range, third is variance, and fourth is standard deviation. So range and interquartile range will go together, and variance and standard deviation will go together. So let's see them one by one. Range is the difference between the highest value and the lowest value in the data distribution. So what do we mean by highest value and the lowest value? So let's take up an example. Suppose we have a data from 1 to 9. So I have sorted this in the ascending order from lowest to the highest. So highest data value is 9 and the lowest data value is 1. So the range will be 9 minus 1, that is 8. So for this particular data value, my range is 9, the highest value, minus 1, which comes out to be 8. So range, that means variation of this data is 8. Let's see the practical use of this range parameter in real world example. So a company is producing some units which has two plants, plant A and plant B, and a manager was asked to record the plant production for first 5 days. Now plant A has a production of 15, 25, 35, 20 and 30 units respectively, whereas plant B has a production of 23, 26, 25, 24 and 27 units respectively. So if I found out the range of plant A, the plant A has a maximum production of 35 and a minimum production of 15 units. So to calculate the range, I need the highest value and the lowest value. So it will be 35 minus 15. That comes out to be 20. So 20 is the range of this particular plant. That means 20 is a variance in the production units of plant A. Whereas for plant B, the maximum value is 27 and the minimum value is 23. So the range comes out to be 27 minus 23, that is 4. This means that variation in plant B is only 4 units production in 5 days. That means plant B is giving more consistent production as compared to plant A. So more consistent production is required to strategize the production of a company. So company will prefer plant A or plant B. It will automatically prefer plant B because plant B was giving us consistent production with less variation, whereas plant A was giving sometimes higher units of production, sometimes low unit of production. So it is difficult to strategize the particular domain. Therefore, this helps us in strategizing the company production plan. So range is very much useful in identifying the variation in the units. Next is interquartile range. So interquartile range tells us the difference between the third quartile and the first quartile. So what is quartile? So let's find out the middle value of the data first. So we have already seen in the central tendency measure that how to find out the middle value or the median. So I have this data, I have sorted them in the ascending order 2, 3, 4, 5, 6, 7, 8. Now if I have to find out the median of this particular data, I'll find out the middle value. So first tree one on the left side, first tree on the right side, and the middle value comes out to be 5. So 5 is my median. That is the median or the middle quartile, or represent the 50% quartile of my data. Now from this median quartile range, on the left side I will again find out the middle value, and on the right side I will again find out the middle value. Now on the left side I have three values, 2, 3 and 4. The middle value will be 3. So 3 represents my first quartile or the 25% quartile of my data. Median was 5, and on the right side we have values 6, 7 and 8. And in 6, 7 and 8 the middle value comes out to be 7. So 7th will represent the 75th percent quartile of my data, because till 5 we have 50% and next is represented by 25%. So 7th contributes to be 50 plus 25%, that is 75% quartile of my data. So let's understand this with the help of an example. So let's say I have this number range 1, 4, 6, 12, 14, 17, 20, 25, 40, 41 and 46. This has been sorted in the ascending order. Now, if I have to find out the median on this particular number, I will calculate the median. So I have first 5 numbers, then I'll leave out this middle value, and then I have again 5 numbers. So median for this data is 17. Now, apart from 17, then I will check for these first 5 values. The median for this first 5 values will be 6. So 6 becomes my Q1. 6 becomes not Q1, basically it comes out to be 25th percentile quartile of my data, right? And then 17 was the 50 percentile of my data, and next on the right side I have numbers from 20 to 46. In this, what will be my median? Median will be 40. So 40 is my median, and this contributes to the 75 percentile quartile of my data. That means at 6 value I have 25% of my data, at 17 value I have 50% of my data, at 40 value I have 75% of my data, and after 40, how many numbers are there that represent the total 100% of my data. So what is my interquartile range? Interquartile range will be Q3 minus Q1. So this is 75 percentile. Q3 is represented by 75 percentile quartile of my data. So what is 75% quartile of my data? That is 40. And what is Q1? Q1 is nothing but the 25 percentile of my data. That is 6. So 40 minus 6 is called as 34. That means the variation in this particular example is 34. And it is also used to plot the box plot, and box plot is also based on this interquartile range only, and it is therefore used to find out the outliers in our data. Next parameter is variance. So variance is called as the average of the square distances from the mean. So let's say, what does it mean? So if I am measuring the height of animals of various cats, and on these cats my mean comes out to be 394. So the height of the first cat was 600 millimeter. The height of my second cat was 170 millimeter. The height of the third cat was 430 millimeter. Fourth cat was 300 millimeter, and fifth cat was 470 millimeter. Right. So I need to find out the variation in my range of the height of my cat. So I'll use variance. Now I have given this mean value that the mean average height is 394 millimeters. Now how will I find out the variance? Variance will be the height of a particular cat minus mean, and then I will square up the value. That means 600 minus 600 minus 394, that comes out to be 206. So 600 minus 394, that comes out to be 206, and square of 206 is there. And then 170 minus 394, it comes out to be minus 224, and I'll square it up. Then is 430. 430 minus 394, that comes out to be 36. Then 36 square, I'll square it up. Then is 300 minus 394, that comes out to be minus 94. So I will square it up. And then is last is 470 minus 394, that comes out to be 76. And I will square it up. And after squaring up, I will add all these numbers. And then I will divide it by the total number of cats. So I will divide by 5 because there are 5 cats, 1, 2, 3, 4 and 5. So my answer comes out to be 21704 millimeter square. So this much is the variation in my data. But does it signify anything? Not exactly, right? Because I will not find height in the millimeter square. So To avoid this, we use standard deviation. So let's first see what is the formula of standard deviation. So standard deviation is basically nothing but the square root of the variance. Now I had find out this variance as 21704, and to find out the standard deviation, I will just square it up, find out the square root of this particular number. It gives out to be 147.3 millimeters. Now this is valid for me because this tells us the deviation of a particular height of a cat from the mean value. I will measure the height in millimeters. So I can say that from the mean, that is 394, my variation in the height of the cat is 147.3 millimeters. It can be above the mean, it can be below the mean. So standard deviation is gives us a more accurate understanding about the variation of the data across the mean. So standard deviation is nothing but the square root of the mean. So if I have to find out the variance was xi, that is the height of a particular cat, minus the mean average height of the cats upon square, and I will sum it up all them, and then I will take up the under root of the all the differences after dividing it by the number of total observations. So this is how I can find out the standard deviation. So standard deviation tells us the deviation from the mean. Now if I find out I have, let's say, 6 balls. Now in this I will say that standard deviation means I can have to just measure the variance. So variance is nothing but the radius of the ball. If the radius of the ball is not varying much, I will say that standard deviation is low because the deviation is less. So I'll say that data with low standard deviation because data is uniformly spread out across the mean. Similarly, now I have 8 balls, but this is totally far apart from the mean. So I will say that data is widely spread and has a high standard deviation in this set of balls. So this is how we can measure the variation in our data sets. So what are the practical uses of measure of spread? It basically tells us that smaller the spread, better the mean represents the data. So in this example of balls where the data was less spread out, I can say that the mean gives us the accurate estimate of the data. But when the larger the spread, that means, let's say, take up example of a musical concert. In a musical concert, different varieties of people participate. Young people also participate and old people also participate. So it is difficult to find out the average age of the participant. In that particular case, when the larger the spread is, then standard variation is used, or variance or range can be used to find out the measure of spread of the data. Now it also tells us to help us to find out the outliers based on the interquartile range, and we need to standardize our data with respect to the mean. So standardization of data will come, we'll see in more detail in the inferential statistics part. So next measure is measure of shape. This we'll see in the next video. So for more such interesting videos, please subscribe to my channel. And if you have any suggestions for me for the videos, please let me know in the comment section. Thank you all.